Check, check, check. What's going on, everyone? How's everyone doing? Happy Friday. Man, it has been productive today. Been creating a lot of content for y'all, and I'm kind of excited for today. I've been working on this Weierstrass substitution. Weierstrass, I can't even pronounce it, and I know my pronunciation is really bad, so if someone corrects me, please let me know what that's going to be. But anyway, this is kind of what we're going to start doing today. I'm going to show you guys the types of integrals that we are going to solve. And we have this guy to thank. Look at this young, handsome German lad. Oh my goodness. So I don't know if he was like the founder of it, but we can contribute, or we can thank him for creating these half angle or tangent half angle substitutions that are going to help us solve a lot of integrals that we have here. So we have a couple trigonometric integrals that we are going to solve. I haven't even tried any of these. To be honest, this is the first time using this substitution myself. So it's going to be kind of interesting to see how it works out. I'm always going to reference these, and I'm going to have them on a separate window on my end. And I would definitely write them down every single time we are trying to do some problems. But anyway, that's basically what it is. So if we look at these integrations or these trigonometric functions, it looks like we can rewrite them using the half angle of tangent, and it creates this nice equations in terms of t. Now, t is going to equal to tangent of x over 2, so we'll plug those back in every time we integrate. But I think apparently it's going to help us solve some integrals very easy. Yes, Theo, there are so many integrals, but you know what? That's part of calculus, baby. And again, this is what I'm going to do today. Today is off trail, but if anyone has any integrals that you guys want to cover together, we can definitely do that. But this is on my agenda today, what I want to do for the next hour and 10 minutes. But if you guys have specific integrals you want to cover, then we'll definitely go ahead and do that. All right, so I'm going to go ahead and move this stuff to my other screen. And like I mentioned, I will definitely reference these, but these were the types of integrals that we're going to start off doing. Again, shell and disks method, kind of struggling. Look at my previous, if you go to my YouTube channel, I went live, I believe it was it Wednesday or Thursday? We covered areas and volumes. So if you go to my YouTube channel and if you go to the playlist, there's going to be a lot of like calculus material, and we talk about area under the curve. So I think it's always fun to look over those videos. But good luck on that. I wish you the best of luck with those types of problems. All right, so let's go ahead and write the first integral that we have. Dx 1 plus sine of x. So as I mentioned, today is Friday. Today is just off trail. So we are going to cover any types of integrals, any types of math concepts that you guys want to review. And this is what I wanted to do today. Oh, pop plastic. Yes, Trib's integrals are just amazing, especially when you learn the trig stuff and you really get comfortable with creating that triangle. Man, amazing stuff, right? All right, so if we're going to solve this, they wanted us to use these ideas. So as I mentioned, t is equal to tan x over 2. So that is the half angle. This is according to what Weierstrass had said. And technically, we could also use that x is equal to 2 tan inverse of t, which is something that we might have to use later on. But then dx is just going to equal to 2 dt over 1 plus t squared. All right. So there's a couple things that we need to rewrite in this integral here. The first thing is that dx, that top value. So dx is going to be rewritten as this, 2 dt over 1 plus t squared. So I'm just going to go ahead and write that, 2 dt over 1 plus t squared. And now we're going to have this over 1 plus, and then as I mentioned, sine of t, or sine of x, according to these substitutions, is equal to 2t over 1 plus t squared. So that's exactly what we're going to put in for the sine. So that is going to become 2t over 1 plus t squared. All right, so let's go ahead and start simplifying this. It's kind of nice because we can get rid of that denominator that we have on both the top and the bottom. And we're going to multiply both the top and the bottom by 1 plus t squared, 1 plus t squared. And that's going to give us this new integral. I'm going to move the 2 on the outside, and we have 2 integral of dt over 1 plus t squared plus 2t. Oh, that's kind of nice. The kingdom on my other TikTok lives or someone else's TikTok lives? As I'm doing that, I'm going to rewrite the bottom. This is going to be t squared plus 2t plus 1. Yo, so this is a very nice integral that we are probably used to seeing. Ah, I feel you. Yeah. Listen, I'm here every Tuesday, Thursday, Friday, and then on Mondays and Wednesdays, I am on YouTube Live, just covering any type of math problems you guys want to do. Okay, so how should we go ahead and solve this? Now this is all in terms of t. This is actually really nice. Change z. Someone said change z. I don't see a z. Oh, thanks for the gift, King Domo. All right, so we're going to go ahead and solve this using completing the square. And as you know, if you guys follow me on TikTok, you guys see some of my videos, I hate completing the square. It's just stupid. I know it's super helpful. I just don't like it. Just don't like it. Listen, guys, Mohammed, good luck with that Calc 2. This is all about just, covering some concepts, but really the way you're going to get better at math is to just see people doing it. You try to do it yourself. We can't perfect it. We're all going to make mistakes. So it's kind of nice just to see other people solve problems and then try to logically think of the steps that I'm doing. But anyway, back to here. We're going to go ahead and complete the square. This is going to become t squared plus 2t. And remember, when we complete the square, we divide 1 or we divide 2 to the b value. So I'm going to do 2 over 2 and then square that. So that means that is a plus 1. Oh, shoot, that's the same freaking thing. Oh, what was I thinking? I don't even have to simplify this. I can just factor this out. I was thinking of completing the square. This just becomes t plus 1 squared. That's really nice. Yo, and now we can go ahead and use some u substitution because u is equal to t plus 1. du is equal to dt. And we're going to rewrite our integral here. And I know we started off with t. Now we're using u's. That's fine. So we have 2 integral of du over u squared. Santiago, don't worry. Just keep grinding, man. I know it's tough, but I promise you it will get better. All right, who can tell me what this is going to equal to? This integral, 2 integral of du over u squared. See, the lighting's a little off today. I'm going to try to change that. Hopefully that's a little better. Trust me, the quality will get better. Once I hit 20K, ooh, it is going to be real nice. The lives are going to continue to get better in quality. Anyway, so now as we integrate this is going to become negative 2 times 1 over u. This isn't going to be 2 ln of u. So now this is going to be negative 2 over u plus c. Let's go ahead and create some space on the blackboard here. And now let me go ahead and change it. Oh, yeah, look at that. I made everything smaller. All right. So now we have, this is negative 2 over u plus c. But our u value was t plus 1. So technically this is going to be negative 2 over t plus 1 plus c. And then don't forget, the t value is going to be that half angle. T is equal to tangent of x over 2. So we're going to go ahead and plug that in. And we're going to have negative 2 over tangent of x over 2 plus 1 and then plus c. Yo, this is kind of interesting. First time I've done that, and that is the correct answer. Nice. So we can thank this Weierstrass, this is our German king, for helping us create these tangent half angle substitutions. Yeah, it's probably changing this. I don't know what the name of this is. I mean, I saw this and I'm like, this is pretty cool. All right, let's go ahead and try a different one. And if you guys are at home, I don't know, I'm curious. By the way, are you guys watching on your phone or are you guys watching on your desktop? I'm really curious about that. Phone, nice. Okay, let me talk about anime lover. I want to talk about this real quick, and then we'll come back to this integration thing. Why does dy over dx equal y turn to e to the x? Let's go ahead and talk about that real quick, and I think it's actually going to be c e to the x. Nice, on your phone. Okay, cool. Just good to know. Good to know. All right. The reason being is because when we start this off, okay, when we're trying to solve this, we're going to do something called separation of variables. So we're going to multiply the dx to the other side. And now I have dy equals y dx. And on the left side, I still have a y and a dx, but I'm going to go ahead and divide the y to the other side. And look what we have. We have dy over y is equal to dx. And now the beautiful thing about this is that we can integrate both sides. On the left side, what is that integral? Dy over y. Let me know in the chat what you guys think that is. On the left side, we're going to get natural log of y. And I guess I'm just going to put the absolute value of y. Thank you, anime lover. And then on the right side, the integral of just dx, since that's a constant, that just becomes x. And let's talk about those adding the plus c's. Let me actually rewrite this. This is technically natural log of y plus some constant 1 equals x plus some constant 2. And then we're going to go ahead and subtract the c1 to the other side. So we're really left with natural log of y equals x plus c2 minus c1. But this c2 minus c1 is just one constant on its own. So I'm just going to do x plus c. And now to isolate the y variable, I'm going to take the e to both sides. And this becomes y equals e to the x plus c. And watch this e to the x plus c. This can be written as e to the x times e to the c. But then e to the c is also just some random constant. So then this equals y equals c e to the x. That's y. Nice. Oh, thank you, Rennie. All right, guys. So let's go back to that integration that we were talking about. Let's go ahead and start off by doing, let's do integral of, let's do dx over 3 minus 2 sine x. Okay, so remember, if we're going to do this W substitution, Weierstrass substitution, keep in mind, since we're looking for sine of x is going to equal to 2t over 1 minus t squared, where t is equal to tangent of x over 2, and then I guess I can also write x is equal to tan inverse of x over 2, if we needed to, tan inverse of t, I'm sorry. And then our dx, which is always going to be 2 dt over 1 plus t squared. All right, so let's go ahead and plug all those things in. So in the very beginning, we have integral of the dx value. That is 2 dt over 1 plus t squared. Okay, again, let me just kind of highlight this in red. We started off with the dx. I said red, but it's not changing it to. Okay, here we go. We have the dx, and we use this value, 2 dt over 1 plus t squared, to plug it into our integral there. And so now we have this over 3 minus 2 times the sine value, which is 2t over 1 minus t squared. Or was it 1 plus? 1 minus t squared. Okay. I'm just going to double check that I have all that correct. Okay, cool. Everything looks good. So now we got to go ahead and kind of rewrite this. So Seth, let me just kind of show you this. These are a nice half angle substitutions, and it's basically a table. Let me just show you real quick. This is a table that I'm using. Okay, so if you can see that, this is a table that I found online. Again, it's called the Weierstrass substitution, and it's kind of derived from the half angle tangent. And we were able to find that sine of x is equal to all these values in terms of t. So it's kind of like a whole list. And as I mentioned in the very beginning, yep, it's a rule. Okay, so let's go back over here. I'm just going to double check that I wrote everything correctly here. Our dx is 2 dt over 1 plus t squared. And then our sine value is going to be 1 minus. Yeah, everything looks good here. Although the sine of x, oh, actually, I lied. Sine of x, it should be 1 plus t squared on the bottom. There you go. Okay, so now, once again, we want to get rid of these denominators. So we're going to multiply both the top and the bottom by 1 plus t squared. And then multiply the top and the bottom 1 plus t squared. Whoops. All right, so let's talk about what's going to happen here. On the top, this is going to be 2 dt over, and then on the bottom, we just got to be careful here. This is going to become 3 times 1 plus t squared minus, I guess I'm just going to do a 4t on here. This is just going to be 4t because the 1 plus t squares on the denominator cancel out. Okay, so let's go ahead and remove or bring the 2 on the outside, and we have dt over, and let's go ahead and distribute that 3 in the parentheses. So then this is going to become 3t squared minus 4t plus 3. All right, so looking at that integral that I have now, everything is in terms of t. We have a beautiful integral that hopefully by now some people might be able to recognize as to what to do next. Anyone have any suggestions? We can factor, maybe partial fractions. Should we complete the square? What do we think? Okay, Seth said factor and then try partial fractions. Yeah, let's go ahead and try that. I'm going to see if I can factor this. So I'm going to do this very as if we're like in algebra 2 or something. I'm going to do the slip and slide. So 2 numbers that multiply to 9 and add to -4. Don't think anything works here, unfortunately. So yeah, Logos said if that doesn't work, then we have to go ahead and complete the square, which is one of my most hated things. I don't know why. I just don't enjoy that. But let me go ahead and erase our work here. Okay, so we're going to go ahead and complete the square. Okay, so I have the 2 on the outside. Whoops. Okay, so I have the 2 on the outside, dt here. And if I'm going to complete the square, this is actually going to get pretty nasty. I have to factor out a 3 from that t squared. And then that 4 becomes 4/3 t plus 3. And so if I'm going to complete the square, I have to divide the -4/3 by 2, which basically means I'm going to multiply by 1/2. And then I need to square that. So that's the same thing as -4/6 squared, which is going to be 16/36. Yo, this does not look very good. Yeah, Serbo Bear, yes, you did. You came for the best part, completing the square. Annoying, super annoying. But anyway, guys, this is now going to become 2 integral. We still have our dt, and then we have, on the outside, we have t squared minus 4/3 t plus 16/36. And then on the outside, we still have a 3. But then don't forget, we're not going to subtract by 16/36. We're actually going to subtract by 16/12. The reason being is because we didn't really introduce a 16/36. We really introduced a 3 times 16/36, which is 16/12. Okay, that's the reason why. Partial fractions wouldn't have worked here, unfortunately, Animal Lover. Anime Lover. I'm sorry, I said Animal Lover. That could be 2. Okay, so now we have 2 times, and then we have, oh, I'm sorry, this was a 3. And then we have t minus, this is going to be 4/6 squared, which is just 2/3. Yeah, we can simplify that later. And then this next one is going to be plus 20/12. Again, I would simplify this now. So let's go ahead and rewrite this. This is going to be t minus 2/3 squared plus, I guess I can make this a 5/3. All right, not terrible. But even then, so this looks like it's going to be an arctangent type problem. And the way we know this is because on the bottom, we have something squared and then something being added together. Okay, so I'm going to make this smaller here. So now we have 2 integral of dt over 3 and then t minus 2/3 squared plus 5/3. Before I can even do the arctangent, I need to factor out the 3 from the bottom. I need to bring it on the outside. So now I have 2/3 integral of dt over t minus 2/3 squared plus 5/9. Got to be very careful here. Okay, so if we're doing arctangent, our u is technically t minus 2/3. Our a value is root 5 over 3 because we got to take the square root of that value. No, I stream Tuesdays, Thursdays, and Fridays here on TikTok, and then possibly Monday or Wednesday on YouTube. I'm trying to figure that out, but it's usually around the same time. Nice, congrats, user 82. And just so you know, Tuesdays is an integration practice, so almost like an integration B. Wednesdays could be something very focused. I'm sorry, Thursdays I meant. Thursdays, yesterday, we were doing, what were we doing? We were doing trigonometry, so we were doing trig identities. And then Friday, Friday was today, off trail. Yes, these are recorded. I post them on YouTube almost like right after the stream. And then on Mondays or Wednesdays, I go live on YouTube and we cover our Instagram solutions that I post on there. All right, so anyway, let's go ahead and finish this up. This is now going to be 2/3 over root 5 over 3 arctan of t minus 2/3 over root 5 over 3 plus c. The only thing that I'm really going to simplify is the constant on the outside. And that's going to become this, guys. This is going to be our final solution. I'll write it or draw it in red. So this is going to be 2 over root 5 arctan of t minus 2/3 over root 5 over 3 plus c. And we can go even further if anything. We can change, don't forget our t value was tan of x over 2. So we just plug that in for the t and then we're done. Not bad. Okay, now I'm going to cover more integrals that I found on here, but does anyone have something specific or a question that they want to cover? Again, this is off trail, so really it's up to you guys what you want to review. This was my game plan, but if you have anything else in mind, please let me know. Bring it to my attention. Okay, so I'm going to go ahead and find the next one that I have here. Yes, Mara. So whenever you have u squared plus a squared, that is arctan. So really, this is the general integration for, it should be u squared plus a squared. And the solution for that is always 1 over a arctan of u over a and then plus c. And it's kind of nice. Now, I want you to think about that. Natural log of any quadratic equation. Are you saying something like this, like natural log of like x squared plus 5x plus 6, like the integral of that, or just do the natural log? Okay, so it's obviously going to depend. Okay, integral of this. So this is actually really interesting. So let's talk about what happens. It looks like we couldn't factor this out. And if you can factor it out, that's beautiful, because now you can go ahead and do, this will become x plus 3 times x plus 2 dx, which is really nice. And then we can rewrite this as a sum of 2 natural logs. Okay, let me know if you guys agree with that, because that's exactly what you can do. And then now you have to think about what the integral for natural log is going to be. So the natural log has a very generic or a very basic integral. Does anyone know what the integral of natural log is going to be? Because if we remember that, then we are good. So who can tell me what the natural log of x is going to be? That's not 1 over x plus 3. Be careful, because if the solution was 1 over x plus 3, if we had to take the integral of that, then yes, this will be natural log of x plus 3. But we have to do something else. Let's actually work those steps out then. And you're going to see that it's going to require some integration by parts. Okay, so the very first thing that I'm going to do, so let's talk about the first natural log, because if we can do the first one, we're going to be able to do the second one. We're going to use integration by parts here. There we go. So x ln of x minus x. So that's what it means. So this is the general solution, or the general integral for natural log of u. Let's go ahead and use u. It is x natural log of u plus c, or minus x, or minus u, and then plus c. Some people write it as u and then parentheses natural log of u minus 1 plus c. Okay. Let me know if I should review why that's the case, or if we can use this this formula already. I could explain it for y'all. Otherwise, I'm just going to do it. Yes, you do it by integration by parts. Should I just work it out? Go ahead and type anything in the chat if you want me to work it out. Okay, so someone said review. That's it. We're going to review why that's the case. All right. So let's start off with that first integral then. And let's go ahead and use integration by parts. So u is going to equal to natural log of x plus 3. That's the best option for us, because we're going to be able to take the derivative of that. So du is 1 over x plus 3 dx. Our dv is just dx. And the reason being is because technically this integral, had a dx in the front. It's just that I separated them. I didn't even put the dx there. All right. So then now, going back to our integration of parts, that means that v is just going to be x. So if we rewrite our ultraviolet voodoo, that's the uv minus integral v du. That's the integration by parts. It is going to be x natural log of x plus 3 minus integral of x over x plus 3 dx. Wait, why do I feel like I wrote this wrong? 1 over x plus 3, and in our v, and that's our x, uv minus v du. Oh yeah, for some reason I kind of confused myself there. All right, so on here we're gonna have to do another integration of parts. So our u is equal to x, our du is equal to dx, our dv is equal to 1 over x plus 3 dx, and our v is equal to natural log of x plus 3. No, wait, why do I feel like I'm doing this incorrect? I am totally not using integration by parts correctly. So u was equal to ln of x plus 3. Our du was equal to 1 over x plus 3. uv minus v du. We shouldn't use u sub for that one. Hold on, I kind of messed this one up here. So let me just kind of create some space here and just rewrite it. Bear with me, guys. Yeah, I don't know why I feel like I screwed this one up. Let's see, because I'm just going to try this again. Our u was equal to natural log of x plus 3. Our du was 1 over x plus 3 dx. And then our dv was dx, and then our v was x. Yeah, that last integral, I don't think you're going to be able, I guess you can use u substitution. It should just be x plus 3. But then we're going to run into a problem here. Let's see if that's the case. Well, that's technically, because you have a plus sign between the ln's. Well, yeah, I'm just doing one natural log separately. I'm doing the first natural log of x plus 3, and then I'll do the natural log of x plus 2 on the second one. I'm just trying to figure out. I don't know if I messed that one up. So Mars said I should be using u substitution for this one. But I don't think that's... Let's see if that's the case. Because if we use substitution for that, that means that u is equal to x plus 3. du is just equal to dx. And so now we still have this x natural log of x plus 3 minus, and then we have integral of our, we don't have x yet, which we'll fix in a second, over u du. But then we use this idea that since u is equal to x plus 3, then u minus 3 is equal to x. And then we're left with x natural log of x plus 3 minus integral of u minus 3 over u. I guess that's going to work. Yep, there you go. Okay, so that's how that works. And then let's just go ahead and rewrite this a little bit. Let me just, so now this becomes minus integral of 1 minus 3 over u du. And we're going to go ahead and integrate this now. X natural log of x plus 3 minus u plus 3 natural log of u, and then plus c. But then let's see if we run into some issues here. So then x natural log of x plus 3 minus our u value was just x plus 3. So this is x plus 3 plus 3 natural log of u, which is x plus 3. And then this is plus c. Yeah, so we totally came up with something a little different there that we shouldn't have done. Somehow I feel like that's not correct because we have the natural log of x plus 3. Yeah, we definitely added something wrong there. Does anyone see or catch what I did incorrect on that one when I was trying to prove the integral of natural log of x plus 3? Because we did integration by parts, which is x plus 3. du is 1 over x plus 3. I'm going to try that one more time, guys. Let me just erase some stuff. Because again, I have a feeling that something is not right there. Oh, no, never mind. No, that's correct. Yes, yeah, you're right, Kiko. You're right, Kiko. I'm going to do the integral of x plus 2. So, yes, this is actually correct. I don't know what I'm confused by the x plus 3. But this is why we were just talking about, Mar, I believe, gave us the integral for natural log. This is why it's better to know that formula. Okay? But that integral is correct. So, I'm just going to show that formula on here. So the natural log of ln of u du, okay, is equal to, I'm just going to check what Mar wrote up on top over here. It is going to be u natural log of u minus u plus c. Okay, so we're going to use that integral that I wrote in green on the top. But that's why, again, if you memorize that, it's going to be a lot easier for us to do. Because otherwise, you have to do these integration by parts every single time. Okay, so now we're going to go ahead. And I'm just erase this part. And now we're going to integrate both of those natural logs. It's going to be much easier for us to do. All right. So let me just change this. Bear with me, guys. I just don't want to erase the whole thing. I'm just erasing things one at a time over here. Okay, so we'll just leave it like that. Okay, so for that first integral, I think we had changed it back. Our u is technically x plus 3. So then this is going to become x plus 3 natural log of x plus 3 minus x plus 3. That's that first one. And now we're going to add the second integral. This is what Kiko Lopez was saying. That's why we have calculators. So true. So then this is going to become x plus 2 natural log of x plus 2 minus x plus 2, and then the whole thing is plus c. So that will be the integral for that whenever you have natural logs inside. Okay? Yes. So logos, absolutely. So it's just like when you do, like when you recognize, like, oh, this is an arctangent. It's nice because now you have to, you don't have to do all the trick stuff that you have. Now, this is pretty simple, right? I was able to factor it out. Okay. Now I'm curious. Let's try to think about what happens when you can't factor it out. So what happens when you have an integral that looks like this, the natural log of x squared? Let's just say, for example, it is natural log of x squared plus 4x, and then we have plus 10, for example. Yes, you need the absolute value. You're right. You're right. You know, sometimes some teachers just don't care, but some people truly appreciate when you put the absolute value. So I agree. Yes, absolute value is going to be important. So Mar, for that one, because our u was x plus 3, I just put it in as x plus 3 and I multiply that out. You should try it out yourself. And if you feel like I was incorrect, definitely try to email me, DM me, or let me know in one of the comments in one of the videos. Wait, Kiko, I think I was done for that one. I mean, all I had to do was simplify. Okay, well, let's talk about this one here. All right, so I have the natural log of x squared plus 4x plus 10. Does anyone have an idea what we should try to do? Now, we can't factor it. Okay, so Manny said just to use subs. Well, let's try it. Can we factor this? Do we know anything that multiplies to 10 and adds to 4? Divide by 21. So Catherine said integration by parts. Okay, let's try some integration by parts. I actually don't know if this is going to work. I don't know if this is going to require the Feynman technique. But again, okay. So someone said complete the square, integration by parts. I think it's going to become definitely some sort of that value. Yeah, so came in and said, okay, we're going to go ahead and do u, natural log of u minus u. Yep, that's going to be the natural log. Oh, okay. So Kiko brought something very interesting. Let's go ahead and find the roots. Let's see if they exist, because that'd be really nice. Even though they're radical, or they're going to be like in terms of a radical form, we can at least separate it. Okay, so let's go ahead and find the roots. Yeah, you can do by parts here, but I'm going to find the roots. Let's just assume, let's see if we can factor it out. That means that x squared plus 4x plus 10 is equal to 0. If we try to use the roots using the quadratic formula, that leaves me with negative 4 plus or minus 16 minus 4 times 1 times 10 over 2. Kiko, check this out. Give me 1 second, guys. All right, so on the root, we have 16 minus 40. Yo, we can already tell that's going to be a imaginary value. So I don't think we're going to be able to do that. Okay, so someone said we use u sub. If that's the case, what can u be? Should we use that whole thing be our, or should we let that whole thing be our u? And to be honest, I actually don't know if this is going to require some higher level stuff. I don't know if this is going to be like a Feynman technique type problem. Try synthetic to find the roots. Well, we just tried it. We tried the quadratic formula, and we wouldn't. It didn't seem like we found a value. But you know what? Let's go ahead and complete the square. Let's just try that and see where that takes us. So we have integral of natural log of x squared plus 4x. So don't forget, we have to divide the 4 by 2 and square it. And that just happens to be 4. So then we have plus 4. And then technically we introduced a 4. And so we need to subtract a 4 there. Whoops, I'm already thinking of the 6. Okay, so then now this becomes natural log of x plus 2 squared plus 6 dx. This is long division with natural log integral formula. Well, what is that? Okay, so I completed the square. So yeah, it's definitely not going to have any roots. Well, let's go ahead and just make this a little easier. Let's see. Let's do u is equal to x plus 2. So then du is equal to dx. So then now I have this amazing looking integral, a natural log of u squared plus 6 du. Well, that kind of helps. And then now we need to ask ourselves, well, how do we integrate this? Something tells me this is a Feynman technique. And if you guys remember the Feynman technique, it's where you have to create another equation in terms of alpha and maybe change this up. This is going to be like natural log of, we can do like u to the power of alpha plus 6 du. Yeah, but that's not going to work. There's just no way. And the Feynman technique is totally advanced. Yes. Last Friday, I was trying to solve something with the Feynman technique, and it looked very similar to this natural log, and I just couldn't get it. Just could not get it. So that was kind of a bummer. Yeah, so you see, this is one of those problems where like it's going to be really difficult to solve. As I mentioned, I just brought it up. I don't know if you can actually integrate this unless you use Symbol Lab or you use Mathway. That's the tough part about this type of problem. So when you have natural logs where you can factor it, by all means, right? We can easily do that. But in this case, you can't. We just can't. Okay, there is a way. I'm interested to hear what that way is. I have to go get my notebook. Okay, so well, I can't do by parts again. You see how it's like u squared plus 6? There's just no way that I can change it. What if you raise it to the exponent to cancel? Okay, I was thinking that. I don't know if this is valid. Okay, so if we make y equal to integral of u squared plus 6 du, and then Kiko's saying, what if I take the e to both of these? Can this actually be correct? Can this become e to the y u squared plus 6 du? Is that valid? Oh, someone said, can we use another u? Okay. So see, that doesn't look like it's going to be valid. Yeah. Let's try. Okay. Yep. Okay, so let's go ahead and try. Someone said try parts again, so another u sub. Let's just try it out. So let me go back to this integral. This is where we're at. Okay, so let's go ahead and try another u sub and see where that takes us. Or, so we already complete the square. Let's go ahead and try to do integration by parts, okay? We already used u, so I'm going to make w equal to natural log of u squared plus 6. And then dw is equal to 2u over u squared plus 6 du. And then our dv is going to equal to just du, and v is equal to u. I think this might work. I think this might work, guys. All right, so if we use that ultraviolet voodoo, I guess it's wv minus v dw in this case because we changed the variables here a little bit. It is going to be u natural log of u squared plus 6, which we already taken care of, minus integral of 2u squared over u squared plus 6 du. Yo. Guys, I think this is going to work. I think this is going to work. Let's go ahead and create some space. I'm kind of excited because let's look at that last integral. That's all we need to integrate. That 2u squared over u squared plus 6. Anyone have an idea what we can do? Someone said partial fractions. I'm thinking partial fractions, but better yet, the integral or the degree of the top is the same as the bottom, so I'm going to go ahead and use long division first. So this is what we have so far. Let me just rewrite this so it's a little bigger. Let me bring out the 2 that's on the outside or inside the integral and do u squared over u squared plus 6 du. And let's go ahead and use long division. So u squared is inside, and then u squared plus 6 is on the outside. What do I need to multiply to u squared to get u squared? That's just 1. And then this becomes u squared plus 6. And we're going to subtract these. Wow. Wow. Because now all we're left with is going to be 1 minus 6 over u squared plus 6, because that's our remainder. You guys, chat, we're doing this. Oh my goodness. Someone said long. Okay, let's continue. Sorry, I got caught up reading the chat here. Now that we have the 2, and I'm not going to worry about the distributing the negative sign just yet, but we're left with integral of 1 minus 6 over u squared plus 6, and this is going to be du. Oh, wow. Because look, u, natural log of u squared plus 6, I have the minus 2 on the outside. The first integral is just going to be u. That's easy. Minus, what do you think we can use to integrate that last one? And Hindi, I go live on TikTok Tuesdays, Thursdays, Fridays. Tuesdays, it's integration practice, so integration B. Thursdays, it's going to be a specific topic. Fridays is off trail, so whatever you guys request. And then on YouTube, I go live on Monday mornings where I cover the solutions to the Instagram problems that I posted. Yes, this is going to be an arctan. So let's talk about our arctan. We just have to be very careful with that 6. Our u is technically just u. We're good. But that our a value is going to be root 6. We have to take the square root of that. So now we have 6 over root 6 arctan of u over root 6. And then we have the whole thing plus c. Oh. All right, so now let's go ahead and distribute that negative 2. Oh, it was kind of, actually, I'm going to remove those arrows so that I can have some space in the bottom. And then so now we have u, natural log of u squared plus 6, minus 2u plus 12 over root 6. I'm not going to worry about taking the conjugate. I'm just going to leave the radicals on the bottom. And now we have arctan of u over root 6 plus c. User, this is a calculus 2, calculus AB, but this is just integrals. They're like fun little puzzles. Life's gift, or God's gift to mathematicians, I guess you can say, or problems that we created. All right, so remember our u in the very beginning was x plus 2. Have it up here. U was equal to x plus 2, so now we just plug everything back in. So x plus 2, natural log of x plus 2 squared plus 6 minus 2 times x plus 2 plus 12 over root 6 arctan of x plus 2 over root 6 plus c. All because the quadratic inside the natural log could not be simplified. That's crazy. That is crazy, huh, guys? Oh, this is perfect. Now take the derivative and see if the calculation holds. Okay, I can take the derivative, or I can do another example with quadratic, but just with a little twist. What do you guys prefer? You want me to take the derivative, or do you want me to do a integral with a different quadratic? Don't worry, user. These are recorded. I post them on YouTube. So right after this, I'm going to download this, put it on YouTube. You'll see the thumbnail. Go to my YouTube. I have the playlist of all the lives that we've been doing this past month, and I have a bunch of other things that that I do that you can review to practice. Calc 1 and Calc 2. Well, Calc 1 is just going to be like derivatives or limits, derivatives, and then integrals. Calc 2 is going to be higher level integrals. So everything that you learn in Calc 1 and in Calc 2. You guys really want me to take the derivative of this, huh? Really? All right. As requested, let's go ahead and make this smaller, and then hopefully I have time for another integral that looks very much like this, but you're going to see that it's going to be a little different. Just a tiny bit. 30 years. That's awesome. Well, now you're here to kind of refresh your memory, huh? Okay. Well, if I'm going to take the derivative, let's start off with that first part. Hopefully you guys can see that. Yeah, I know it looks kind of small, but let's go ahead and we have to use the product rule for this first section. So this is going to be the derivative of x plus 2, so 1 times natural log of this whole thing, so x plus 2 squared plus 6 plus x plus 2 times the derivative of natural log, which is 1 over x plus 2 squared plus 6, and then times, up on top, I'm going to do the chain rule. So 2 times x plus 2 minus that second part. I'm going to highlight that or in red there. So that's just going to be minus 2, which is really nice, plus 12 over root 6 times arctangent is 1 over this whole thing, x plus 2, x plus 2 over root 6 squared plus 1 times the derivative of that. So that's just going to be 2 times x plus 2 over root 6. Yo, should I continue or should I just go to the next integral? I mean, we just have to, is this fun for y'all? Riso, yes, TikTok on Tuesdays, Thursdays, and Fridays, and then on YouTube, I go live on Monday mornings where I cover all the solutions to the problems that I post on my Instagram page. Okay, yeah, you guys see, so I took the derivative. It's kind of fun, right? Should I continue or simplify? And okay, I'm seeing next integral. I'm seeing simplify. Friday night calculus, exactly. Okay, go to the next one. Go to the next. Okay, if I simplify this real quick, I'm not even, just watch me do this, okay? And then we can continue with the problems. Okay, so this is going to become natural log of x plus 2 squared plus 6. Technically, this is the only thing that should be left over. Everything else should cancel out, which I'm hoping is the case. So this is going to be 2 times x plus 2 squared over, this was like x squared plus 4x plus 10 minus 2 plus, guys, this is terrible. So the root 6 cancels out, and then this becomes a 24. And I'm probably already making mistakes here. But then this becomes x plus 2 squared over 6 plus 1. Have to multiply everything by 6. Yeah, I'm just going to go to the next one. This isn't fun. Let's try a different integral, okay? Because I have like 20 minutes, and I really want to do something like this. Because Mar was talking about natural log integrals. Let me show you one that looks very similar. I'm sorry to disappoint. It just didn't look fun, those derivatives. But anyway, I do have a book of 1,000 derivatives. If you guys want to get cracking on those, you're more than welcome to. Okay, check this one out. So it's going to be integral natural log of x squared. Let me just make sure that it works. Okay. No, this one will be as fun. Let's change it to this one. Okay. All right, guys. So I don't think this will simplify. So x squared plus 4x minus 4. Very similar. Oh, thank you, user. Yeah, it's kind of fun. Have you done derivative 1000 already? You know, one of the things here, you can technically generalize this. I can go ahead and do, what happens if we have natural log of ax squared plus bx plus c? And you can get cracking on that. Or maybe I can make a video on that so that you can see what happens when we generalize it. But back to the integral that I introduced. Any suggestions, guys? This looks very similar to the other one, but you're going to see it's just a tiny bit different. Okay, no one's saying it, so I'm just going to start off by completing the square. Let's just do that. So natural log of x squared plus 4x. Don't forget, I have to divide the 4 by 2 and then square it, which happens to be 4. So I introduce the 4, but then I have to subtract the 4. That's part of completing the square. I read the chat. I hate completing the square. I absolutely hate it. I think it's the dumbest thing ever, but obviously it's useful. Just because it's useful doesn't mean I can't hate it. You know? Just because I know vegetables are good for me doesn't mean I can't hate onion and garlic. All right, so this becomes x plus 2 squared minus 8. All right. What should be the next step? Let me know in the chat. Let's do some u substitution. U substitution. All right, so u is equal to x plus 2. Very similar. Keep this in mind. Du is equal to dx. So now let's rewrite this. Natural log of u squared minus 8 du. Do the same thing from last time. Exactly. So I'm just gonna complete this. So this is where we got stuck last time, and someone came in and said just use integration by parts, and that's exactly what we're gonna do. All right. We're already using u, so I'm just gonna use w, and that's gonna be my entire natural log. dw is equal to 2u over u squared minus 8 du, and then dv is equal to the du, and v is equal to u. Yo, so let's go ahead and rewrite our integration by parts here. This is going to be u natural log of u squared minus 8 minus integral of 2u squared over u squared minus 8. Not bad, huh? All right, trust me. The reason why I'm saying this is different, because look at the bottom of that integral. This is u squared minus 8. Typically, or the last problem we had, it was u squared plus 6, which we knew was going to be an arctangent. HD, I said, yes, this is calc. So this bottom is going to require something else. But let's go ahead and simplify this. So I still have u natural log of u squared minus 8. Let's go ahead and pull the 2 out like we did last time. And then we have integral of u squared over u squared minus 8 du. And someone said it. I think it was, who said it in the last one? I think it was Mar that said this. The way we're going to simplify this is using long division. So we're going to take that u squared that's on the inside and divide it by u squared minus 8. And what I'm dividing is this part. It's the integral part. Why? Because the degree of the top is equal to the degree of the bottom. Kiko, you fell for it. It is not arctan. Keep in mind, it will be arctan if it was a plus. So let me show you why it's not arctan, okay? It's going to be a little different. That minus changes everything. I think the hardest topic in Calc 1 is more than likely going to be like some integration stuff. So like maybe disk method and volume and all that. Handyman, hyperbolic sign, maybe, I don't know. Let me show you. Let me show you how I'm going to simplify this, okay? So using long division, what do I need to multiply to u squared to get u squared is 1. So that's u squared minus 8. And then when I subtract this, I get plus 8. So this is my new integral, guys. U natural log of u squared minus 8 minus 2. Let's not worry about the minus 2 just yet. This is going to be 1 plus, the whole thing is an integral, 1 plus 8 over u squared minus 8 du. All right, I'm going to make some space on the blackboard here. And guys, this quality is going to get so much better. Apparently, if you reach 20K on TikTok, you can now like live stream using OBS and stuff. And the quality is going to get so much better. So please like this video and follow, or like the live, and then follow me if you can, please. Okay, so we have u natural log of u squared minus 8. If I distribute the 2, or the negative 2, this is going to become negative integral of 2 minus 16 over u squared minus 8 du. That's pretty simple. That first one, integral of 2, that's just 2u. So u natural log of u squared minus 8 minus 2u. And then we still have minus integral of 16 over u squared minus 8 du. That's the toughest one. Kiko, yes. But then don't forget, if you're going to use arctan, you have to take the square root of that negative 8, and that's not going to happen. Or unfortunately, that just won't work. Okay, let me grab something to drink real quick, and I'm going to show you how to finish this off. All right. So check this out, guys. We are going to have to use partial fractions for this one. So this is where things get tricky. If we don't know arctan, then we have to use partial fractions. This bottom is going to turn to 16 over u squared minus 8. Has to be some sort of u plus root 8 plus b over u minus root 8. You see how complicated that gets? You know what it could be? But here's the thing. I don't know the inverse hyperbolic sign. So we're just going to have to use this method. But you let me know if that's the case once I get my answer, okay? All right, so if I use partial fractions, this means that the numerator, 16, has to be equal to a times u minus root 8 plus b times u plus root 8. Guess what? I have to make some more space on here. And once I complete this with the partial fractions, we are going to have to use, some people called it like the hide method. I forgot. Someone came on here on one of the streams and definitely mentioned how to simplify this better. So on this partial fractions, on the left side, notice that we can make u equal to root 8. And that's going to make our equation equal to this. 16 equals, when you plug in root 8 to that first parentheses, root 8 minus root 8 is 0, so that cancels out. So we're left with b times 2 root 8. And if I divide that to the other side, that's going to give me that b is equal to 8 over root 8 is equal to b. Let's just actually simplify this one for in terms to simplify it by multiplying both the top and the bottom by its conjugate. And that gives me that this is just equal to 8 root 8 over 8, which is just root 8. That's really nice. Okay, so now we know that b is going to equal to root 8. Let's do the same thing for when u is equal to negative root 8. So we still get 16. And then when you plug in the negative root 8 for the a, you get a times negative 2 root 8 plus the b cancels out. So that's really, there's nothing there. And then so now we're going to go ahead and divide the negative 2 root 8 to the other side. So a is equal to negative 16 over 2 root 8 is equal to a. And I believe we can simplify this to just negative root 8 is equal to a. And then now this is our new integral, guys. We have u natural log of u squared minus 8 minus 2u minus, and then we have integrals of negative root 8 over u plus root 8 plus root 8 over u plus root 8 du. And now this, we're almost going to finish this. Let me go ahead and create some more space. And this will be our grand finale, guys. This is the last problem for today. Catch me on YouTube Live on Monday morning. And then back here on Tuesday with some integration B stuff. Integral of e to the x cosine of x. Yeah, we can definitely talk about that later. Okay? And then so now we have u natural log of u squared minus 8 minus 2u. And then this was already a minus, I believe. So we're going to have plus root 8 natural log of u plus root 8 minus root 8 natural log of u plus root 8. You see what happened to our radical just because it was a minus 8, not a plus 8? YouTube, 10 a.m. my time. I know it's a little unconventional. I'm going to try to find a time that works for more people. All right, guys. Well, remember, u was equal to x plus 2. In the very beginning, u was equal to x plus 2. So that's exactly what I'm going to plug in there. So I have x plus 2 natural log of x plus 2 squared minus 8 minus 2x plus 2 plus root 8 natural log of x plus 2 plus root 8. It doesn't even fit, guys. Minus root 8 natural log of x plus 2 plus root 8 plus c. I think that one was a minus root 8. For the b, it was a minus. So I'm going to change that right now. That was a minus. This was a minus. And then the last one was a minus. My bad. Oh, Lordy. All because we started off with a basic integral of natural log of x squared plus 4x minus 4. And that's how we solve that. And if anyone is interested, go ahead and take the derivative of that and see if that's what we get. This was fun, huh? So let me know on Tuesdays. I am going to do some integration B practice. So we're just going to have fun with some integrals. On Thursdays, I do math survival skills. So we're going to practice a specific topic that you guys request. Last week or yesterday, we did trigonometric identities. But if there's anything that you guys want to do, feel free to email me. Or you guys can comment on some stuff in my videos or on my Instagram. I typically would read the comments more on here on TikTok. But if you guys email me with some problems like, hey, can we review this? Then I'll try to make some, I'll try to make that the topic if I see that that's well requested. Or maybe we should start like a Discord or something so that way we can all just gather in one place and be like, yo, talk about this on Tuesday, talk about this on Thursday or Friday. Let me know if Laplace transforms. You know what? Not so much. I've been dabbling in Keishan. Yes, e to the x cosine of x. I believe for that one, there needs to be some parameters. So that way we can use the Feynman technique. But if I recall, that is a Feynman technique, which I've yet to perfect. That thing is so annoying. But yeah, let me know what you guys think. I don't know. Should we start like a Discord so that we can all just hop in there and just post our problems? And that way, okay, so I see the Discord. Yeah, I think that would be really nice. That way we can all easily communicate and I can be like, all right, the live is on there. We can just hop on and discuss any problems that we might have. Anyway, guys, so I'm going to head out. I hope you guys have an amazing Friday. I hope you have an amazing weekend. I'm going to see you guys Tuesday, Thursday, and then Friday here on TikTok. And then on YouTube Live, I go live on Monday morning. All these things are always pre-recorded, and I'm going to post them on my channel. So if you guys want to look at some specific problems, you guys are more than welcome to look at that. But anyway, I hope to see you guys real soon. Don't forget to like, follow, subscribe. Please, I love all the support, and I appreciate all you guys who are here to just talk math. I mean, that's the fun part. All right, everyone. I hope you have a great weekend. I'll see you soon. See you next Tuesday.